In the last lesson, we talked about how the periodic table shows an average atomic mass for an element, and how that average, or why that average is based on isotopes. And so today we're going to talk about how you calculate how that average was calculated. So we're going to calculate the average atomic mass of an atom or of an element along with the percent abundances. That'll be in the next video. So for this lesson, we're going to look at calculating the average atomic mass of an element given percent abundances. We'll do the second one on the next lesson. So we're going to be here. So to start with, how do you calculate an average? And so if I asked you to calculate the average test score for a class with scores of 92, 78, 99, 84, 86, 71, 77, 93, and 80, you would do so by adding up all the numbers and dividing by the total. So if you want to do that quick, you may. You should come out to, I believe, 84.4%. Should be your percentage for this class. When we talk about the periodic table and averages, and we talk about the average atomic mass of an element, we are talking about what is called a weighted average. Meaning there are two things you need to have. You need to have one, the mass of the isotope, and two, the natural abundance, or how common that isotope is. So it's expressed as a percentage. So we call this natural abundance or percent abundance. Would be another way we could write this. So this can be percent abundance. And so we're going to look at copper to start with. So copper has two naturally occurring isotopes. They are copper 63 and copper 65. Copper 63 has a percent abundance of 69.17%. So this is important. And the mass of copper 63 is rounded up from 62.94 AMUs. Again, AMU is atomic mass units. So now copper 63 has 69.17%. That's the percent abundance, and the mass is 62.94 AMUs. Copper 65 is only 30.83% abundance and has a mass of 64.93 AMUs. Your task is to determine or calculate the average atomic mass of copper. So you will notice first that your percentages 69.17 and 30.83 should add to 100%. So if these don't add to 100%, it should be real close, 99.99. If you're off by like a whole percentage or something like that, we miscalculated somewhere. But that's 100%. All right, so we need to determine the average mass of copper. To do that, we said we needed a mass and a percentage. So what we're going to do is we're going to use your average atomic mass is equal to your mass times your percentage. So mass 1 times percent 1. And 1s and 2s don't really matter which one's which. You're going to add to it mass 2 times percent 2. And sometimes we can have more, so plus mass 3 times percent 3, etc. So for this, I have 62.94 AMUs, so my mass. So my average atomic mass equals 62.94 AMUs times, I got to make this a decimal. So to make a percentage a decimal, we're going to divide by 100 or move the decimal 2 places to the left. And so with that, we're going to get 0.6917 plus mass 2, which we said was 64.93, times 30.83%, so 0.3083. And if you take and you multiply 62.94 times 0.6917 plus 64.93 plus times 0.3083, you should come to an answer of 63.55. and my unit's going to be AMU. Should be your average atomic mass for copper in this case. And it should be very, very close to what's on your periodic table. So if you check copper out, should be very close there on average atomic mass. Here's a chance for you to try one. So I'll walk you through this one. You'll get a chance to practice on the next one on your own. If you want to, you can pause me and then try it and fast forward to get your answer. The two most abundant isotopes of carbon are carbon 12 and carbon 13. So carbon 12 has a mass of 12 AMU, 13 has a mass of 13 AMU. The relative abundances are 98.9% and 1.10% respectively, meaning the 98.9 goes with carbon 12, 1.1 goes with carbon 13 because 12 came first, 13 came second there. So calculate the atomic mass of carbon. So I know my atomic mass is equal to mass 1 times percent 1. So my mass 1 is going to be 12 AMU times percentage 98.9, so 0.989 plus mass 2 is 13.00 AMU times percent. Make sure you move this 2 places to the left. This is going to be 0.0110%. So if you multiply 12 times 0.989 plus 13 times 0.011, you should come to an average atomic mass of carbon of 12.011 AMU, or you can leave it at 2 decimals, 12.01 AMU. Your sig fig, significant digit, should end up about the same as what you had here. So I had 4 there, I have 4 here, I had 4 here, I have 4 here. That should be the same. Percentages, don't worry about, don't calculate that into your sig figs, but use the masses. That would be a good way to do it. All right, your turn. What is the average atomic mass of boron if it exists as 19.90% boron 10 with a mass of 10.013 grams per mole, or AMU? Those are both the same thing. And it's 80.10% boron 11 with 11.009 grams per mole, or AMU, same thing. So pause this, work through that. Your answer is on the next slide. So your answer on this one should be 10.81 grams per mole, or you can write it as 10.81 AMU. Either way works. We're going to use this for sure second semester, so if you get used to that, that would be a good thing. But those are both the same, and that's your average atomic mass for boron. All right, here's some closure questions. Make sure you can answer these. So the first one is, how do you calculate the average atomic mass of an element? So you should be able to explain to me how to do that. And then you can calculate the average atomic mass of lead, given the isotopes and percentages there. If you're looking for percent abundances, we're going to discuss that in the next video. So you can go ahead and click on that. Otherwise, thank you for your time and attention, and I will see you in class.